Hello. Hey, hi everyone. Good morning. Hey, good morning, Mose. Hey, Diwali. Cool. Yeah, hey, morning, Emmanuel. Cool. Okay, there are less participants in the class. The time is already there, right? Cool. So, can we get started, right? What say? Because that's the one of the topics which is required for the production level, what say, applications, right? And this is the concept or the topic which will be helping you in order to deal with real-time bugs and issue, right? So yeah, a quite interesting and quite important topic onto this one, right? So cool. Without a further ado, let's get started. Let me just share the screen and let me grab a new whiteboard for the day. Yes, I guess the screen is visible, right? All right. So let's get started. GL week 2, right? I guess it's week number 2, I guess. Yeah, it's week 2. That is the Azure monitoring. All right, sharing the whiteboard link. Yeah, the whiteboard link is in the chat and let's take it further ahead, okay? So agenda for the whole session is going to be something like this. What problems we face in production apps or production deployed solutions, okay? We'll be listing out the problems actually, right? What we are facing, right? And how to solve that, so and so. The thing that which I am very much concerned here is that we need to understand the what say deployment platform actually. Okay, what do we exactly mean by a deployment platform? Then after that, we will be moving on to streams, or sorry, not the streams, but the logging, log monitoring actually. Then we'll be moving on to KQL, which is data streaming. And then we can move on to yeah, microservices architecture. And after that, we can straight away move on to the demo. So demo is again Azure Application Insights. And then I will be showing the use case of KQL, microservices architecture, data streaming, and many other things. Okay. So this is one of the topics that which you will be uh, doing in the production level environment, right? Cool. So take a look at the agenda, everyone. Right. So first, let's be comfortable with the agenda, whatever we will be going to deal with this particular part. There we go. Okay, cool. So any doubts or any concerns of this particular agenda topic? Fine, cool, comfortable, right? Okay. Now let's get it further ahead. Okay. Now let's go down to the first particular thing. So what's the problem we face in the production deployed solution, right? See, first thing, let's make it clear that there will be three particular environments which we will be working. Okay. That is dev, test, and production, right? This I guess everybody know, right? And yes, obviously this will be going to change according to the company or the industry standards which you will be going to do. So typically we have one environment of development or one environment of test typically, but again, that's not the whole generic thing or solution, right? And for test we have one, then production we have one, so and so, right? Now, what I wanted to highlight onto this particular point is that you see, you need to be very clear on one concept, that how we will be going to code or how we will be going to design the solutions, right? There is obviously a difference between engineering and architecting. How many of you have got my point? There is a difference between engineering and architecting. Agree? What say? So what I wanted to specifically highlight here is that if you have what's a coded up an application, and this is an web app. Okay, you have coded up, you have tested it, the web app, right? You have tested the web app, and then you have put it onto the production line, right? How many of you are on this stage that okay, fine, if we have deployed the web app, right, it's not 100% guaranteed that our engineered solution will be working fine. What say everyone? Make sense? First, let's discuss the prerequisites of this topic, right? Means it is seriously not possible to have a 100% flexible solution for everything. Make sense? This is also called as law of machine. Law of machine or law of engineering, what do we call it? It says that none of the machine will have 0% error. So 0% error is not the what say ideal thing. Means every machine will be having some errors, some bits and bytes of errors, right? So see, for this error means we always make it like that, and okay, fine, it's not the 100% case. I hope you got the point. It's not the 100% case. It will be approximately 90% fine, and 10% it might be some of the errors. Not exactly errors, but 10% we are keeping it on the flexible terms, right? 10% it the application cannot behave over how it was expected to be. What say everyone? Make sense? So this is all about the 10% thing, right? Now tell me one thing. How many of you agree with me that Amazon, okay, suppose Amazon.com. So this is an e-commerce website. So this e-commerce website will be having software engineers. Make sense? And this e-commerce website will also having hackers. Yes or no? Like Amazon should have some hackers in order to prevent the new hacking techniques. How many of you have got my point? What say everyone? In order to prevent hacking, what say? A hacker knows how to hack, so hacker will be preventing other hackers. What say? Make sense? Yeah. So this is my point actually. I see, that's fine. We have studied Azure, we have done our thing, we have studied many of the services, right? But what is the thing we have to highlight, or we have to be focused on this 10% part. And this 10%, it can be anything. It can be hacked, it can be reversed engineer, it can be, I don't know, man. It can be any other things like errors, like whatever the device incompatibility issues, whatever. So see, the session is actually focusing on this 10%. What if we have errors in our application? What if our production level ready application is throwing up some what's it try catch blocks or some exceptions? Makes sense, right? Okay. So this is the 10% of the topic that which we will be going to discuss now. Okay. Now, let us come to the same thing. What problems? What problems will be in production deployed solution? How many of you can highlight any of the problems? Problems, errors, anything. what does your take on this one? What say everyone? What say everyone? Any problems? What do you think? Any problems? Anyone in the class? What say? Performance issues, okay, makes sense. Performance issue will be in the context of device, right, Emmanuel? Or in the context of application itself. Oh, sorry, not application. I should not write it application. I should be in the context of solution. Means performance issues can be in my client device or can be it in my solution. Both are possible cases, right, Emmanuel? Yeah, good one. What can be the other? Go ahead. You all are doing good. What can be the other problem? See, I hope everybody got the question, right? Deepavali, Sanchez, Emmanuel, Eric, Lakshman, Luan, Mosai, right? Got it, right? I hope you understood the question here. What problems will be faced in the production deployed ready solution? What's it? Security. There we go. Can be threats. It can be risks. Can be vulnerabilities. Yep. Go ahead. Come on. Come on. Think in the context of no, no, not mechanism and monitoring and login. No, no. Think in the context of scalable solution. Think in the context of architecting it. What if we have got billions and trillions of users, right? So concurrent request, right? So it's all about the architecting. Makes sense. There is scalable solution. Yeah, cost. Yes, yes, yes. Right. So now let me highlight this particular point here is that yes, that these all issues, these all issues will be these all issues will be categorized as logs. Make sense? Logs are nothing. These are the events. These are the messages. These are the activities. Make sense? Okay. The best example for understanding logs will be how many of you are using Android phone? Android or iOS? Apple, what say? Anyone Android phone? Okay, no one. Android. Okay. How many of you have seen some screen like this? What say? Like something like this in the Android 4 on in your mobile device, iPad, Apple, Mac, whatever, right? What say everyone? Nobody have seen this kind of thing. Okay, no one. Do we have the same thing in the iOS application crash? Yeah, something like this, right? Means I don't know, means means you haven't used Android, but that's not the thing. But I hope you got the point, right? How many of you have seen in iOS something like this? Application has crashed. third-party issues, something like this, right? What say? Makes sense. I'm trying my level best to make the context of this particular session, but I hope you got the point, right? Something around this, right? One second, Windows app crash logs. Yeah, have you seen this blue screen? This you must have seen, right? It's on Windows, right? What's everyone? Have you seen this thing, right? The blue screen error. Okay, to remove this. Okay, makes sense. So see, what my point here is that this blue screen or whatever the screen it is, see, this is actually an error, right? What say everyone? How many of you have got my point? It's an error or not error. It's a problem, right? Okay, so what is my specific thing is that this problem will automatically, this problem will be invoking the system to generate a crash report. It come in the corner, right? Send the report to Microsoft, something like that. How many of you have seen that? Save the crash report, something like that, right? So see, what my point here is that these all are the issues of the applications if they are in the production environment, which means please pay attention, which means every problem or every, what say, suppose this is an app, this problem ran in, means this app ran into a problem, and this problem will be generating the logs. Make sense? Now what are logs? Logs are nothing, these are the messages. Okay, these are the messages, and logs can be categorized with 3 or 4 contexts: log I, DW, and log E. Log I stands for information log. Log D stands for debug log. Log W stands for warning log. Log E stands for error log. Make sense? How many of you have got my point? Which means the messages or the logs will be further categorized into 3 or 4 verticals. Make sense, everyone? Fine, right? Yeah. So this problem, whatever it is have here, it will be generating the logs, and logs will be having the 4 particular parameters, right? And these 4 parameters are further classified into I, D, W, and E. Okay. Now, please pay attention that this is not something new. Okay. Which means whatever I am doing, please now pay attention. Okay. How many of you have Amazon app in your phone? Amazon e-commerce app. What say? Everybody does some shopping, right? What say? So if you have opened the Amazon app, you will be going to something, right? Or means to some shopping or shopping like home decor items, something like that, right? I'm not a fashion this guy who loves to shop, but yeah, something around that, right? And you have got some perfumes. See, it means you are doing some activity and you have selected the perfumes, and then you add them to cart. Okay, and then you forgot to check out, something like that, right? Now can I call it like that? From here to here you have only done the activity. What say? Make sense? Means you're doing something activity in the app. You are clicking somewhere, you are saving somewhere, you are wish listing somewhere, you are doing something, adding to cart, checking the review, something. Please pay attention. These logs or these activities are actually the logs only, simple. Okay, that's all. And these logs will be further be divided, whatever we have said, I, D, W, and E. All right, makes sense? Fine, cool, comfortable, right, everyone? Okay. Yes or no, please. If you have any questions, feel free to ask in the class, please. Deepavali, any questions? Sanchez, Loan, Mose, Eric, Lakshman, Emmanuel, anyone? Okay, cool. Now, just think in the context of this one that you have clicked on this particular button, that is add to cart, right? And then there is one message which has appeared here that failed to add in cart. What say? Can be a possible scenario, right? How many of you have got my point? Okay. So what type of log it will be generating this particular case? What say everyone? What type of log it will be generating this particular case? Log? Which type of log? I, W, D, which one? Good. Exactly, there we go. That's an error. Simple, right? What say everyone? Make sense? Okay. And if you have added the item successfully, right? Okay. Then what type of log it's going to generate? Log I, simple, right? Okay. Now, please pay attention that log D is basically used in the development context in order to debug the thing that is in the context of developer or developer, right? Warning will be used whenever we have some memory leakage, core segment fault dump, something like that. Okay, memory leakage or some networking latency issue, something like that. Okay, makes sense. Now, please pay attention that this is, see, you need to understand the concept here. The thing here is that you will be using a device. Makes sense. You will be using a device. That's a phone. Phone is having one app, that is the Amazon app, right? And this Amazon app is getting the data from the Amazon server. Make sense, everyone? Yes or no? This is your device, and this device will be getting the Amazon app, and this app will be getting the data from the server. Yes or no? Make sense? This is the concept of API. How many of you remember API? What's everyone? Make sense? Right? Yeah. And which type of API? Get API. Yes or no? Because we are getting the data from the server. This thing we have discussed, right? How many of you have got my point? This thing we have discussed, the get API, right? So please pay attention. Now, this is the Amazon server, right? We'll be getting up the response from there, and then we will be doing our things, whatever we have got. Now, whatever the problems or whatever the logs are getting generated, the logs will be also be sent on to the Amazon server. Make sense? Means the logs which you are generating onto your mobile device, that will be also sent on to the Amazon server. Make sense? Yes, no, fine, cool, comfortable, right? What say? The reason is because they also need to have information that my Amazon app version 2.4, suppose, or 2.5 is not working on Pixel devices. How many of you know about Google Pixel devices? Right? These are the Android devices which get the prioritized latest Android updates. What say everyone? Make sense? Fine, right? So they also need to have a particular view that, okay, fine, is my app is working on a specific device? Yes or no? If it's not working, then what shall I do? Right? Something like that. Makes sense, everyone, right? How many of you have got my point? Shall I take it further ahead? What say everyone? Can we move ahead? Any questions? Please go ahead if you have any doubts. Okay. Now, whatever the logs we are having or generated from multiple places or multiple devices or multiple apps, right? Okay, so these will be going on to a centrally located server, right? Okay, and this server will be storing the log, right? Suppose, I don't know, maybe this one, log, right? Let me write as logs. And later we need to, later the company need to understand the logs. What say? Because these logs will be later be sent on to some machine learning algorithm, ML, DS, AI algorithms, and then the prediction will be generated or the recommendation will be happening, right? What say everyone? Make sense? How many of you have got my point? See, suppose there is one entity, suppose let me just make it a person. Suppose this person is me, right? So my name is Sid. I'm originating from India, right? I have worked for the UK investment banking majority of my whole lifetime, right? I have been on to several technologies, but let's consider Azure or Microsoft. And yeah, my suppose my what say my daily routine or something like this, that I like orange juice, right? Right. So these are my entities, name, place, whatever. I hope you got the point, right? And my favoritism is here is that orange juice. Makes sense. What's everyone? Fine, right? So, so is something like this, that okay, the person who is having these characteristics, right, or these activities, that person would might like orange juice. What say? Makes sense? Or let me make it more clear to you all. Okay, that is, this is me, Sid from India, right? And I love to have some new tech gadgets, right? And I have recently spent $500 averagely in a quarter for gadgets, for new tech gadgets, right? Okay, makes sense? Now, now see what is the benefit company is getting from here. That means if a person is spending average of this much amount in the context of gadget, yes or no? Makes sense? Then the company can calculate that, okay, fine, this person is having a salary of $700 per month. Makes sense? What's everyone? Fine, right? Means according to the activities, I can calculate something else. My living standard. How many of you have got my point? Yes or no? Yeah. Eric is saying yes. What about others? Please do type in the chat. What say? Yeah, right. So this is the basic thing. So from the logs, we have gathered some information and we will be applying our machine learning, data science, AI knowledge, and then we will be generating the recommendations. Right. In similar case, suppose there is one more person. She is a girl, right? Her age is 25 and she has just passed out from college and she is now working as an intern, and she spent around $40 per month, right, in I don't know, shopping of clothes and all, right? Something like that. Makes sense. And on the other hand, there is one more girl, but she's different. Maybe she's, one second. Something like this, right? Okay. and her age is 26, suppose. And yeah, and she's an intern or something like that. So can't I do something like this? This person is very much interested in shopping, right? So can't I generate some recommendations on the basis of some similar characteristics, and these recommendations I will be showing to some other person? What say? Make sense? Means another person who is having some kind of different or some kind of same activities, right? What say, everyone? Make sense? Yeah, right. What say? Deepavali makes sense, right? Lakshman, what say? Fine. Any questions? Okay, so yes, please pay attention that whatever I have taught you now is all about the logs, and logs are beneficial for the production environment as well, and logs are beneficial for generating the recommendations in the context of ML, DS, data science, deep learning, AI, deep learning, agentic AI, RAG, and many other things. Okay, these are the AIs of solutions, right? I hope you got the point. Simple. Okay, so this is the importance of logs here, everyone. Okay, and please pay attention, logs are not something new. This has been into the industry, or this has been onto the IT since last 10-20 years. Okay, Java application also uses log, Python application also uses log, Ruby, Rails, right? Many applications which also use log. C sharp also uses log. Okay, makes sense. So what we will be specifically going to do, we are going to analyze the logs. Makes sense? How many of you have got my point? How to analyze the logs? What say, everyone? On the same question, right? How to analyze the logs? We have understood the log, but how to analyze the log? There has to be some particular, some way to analyze the logs, right? What say, everyone? Make sense? Okay. So what are the ways to analyze the log? KQL. Yesterday class, oh sorry, in the last class we have done about what's that? SQL, right? What's the full name of SQL? Who can highlight what's the full name of SQL? Come on, structured query language. Yesterday class means on the last class we have done SQL, right? If I'm not wrong. Yeah. So SQL. So SQL is basically for the what say it's called as a structured query language, right? And this is basically for cold data. Yes or no? How many of you have got my point? It is for cold data, right? And KQL is called as push to query language, which is for hot data, which is basically nothing but this kind of streams data. Make sense? Right, everyone? Okay, makes sense. That's all. Okay. Now, yeah. So now, okay, yes. And now tell me one thing, that if I will be going to Amazon.com, the home page, right? And from the other hand, I will be going to orders page, and from again the other hand, I will be going to what say the profile page. So if the profile page is not working, suppose if the profile page is not working, then will the whole Amazon app will be not working. If one of the component is not working, then the whole app will be not working. What's everyone? Obviously no, right? How many of you have got my point? Right? If one of the component is not working, then it's not necessary that the whole app will be not working. Right? What say? Make sense? Okay. So this is the whole view for this, right? You need to understand onto this context that every part or every endpoint is a module. M1, M2, M3 modules. Okay. This leads us to the concept of modular programming. Okay. How many of you have got the way? Means how many of you have got the term modular? What say? Every context or every program is a modular way. Okay, something around this. And please pay attention that every module is dependent on to some other of each other context, but it's not necessary that the dependency will be going to fail there, right? What say? Make sense, everyone? So modular programming is the way of programming of the thing. And in the context of architecting, it's called as microservices. Okay, so what do you mean by microservices? Microservices are typically the modular programming, but microservices segregate the modules or divide the modules in the context of services. Make sense? Okay, cool. Any questions, any doubts to be asked? Okay, any questions, any doubts to be asked? What say, everyone? No? Okay, cool. Now, microservices is a big topic, so that's the main reason. I have something for you. How many of you like surprises? What's everyone? Anyone? Surprises? No? Moss is saying, or Deepa, why Deepavali? Why no? Seriously.
No, I really don't.
Seriously, why? But I guess typically ladies likes to have surprises.
Uh, no, I do like to plan ahead and things go according to plans and routine. Um,
Oh my God. That is not life, Deepavali, right? I hope you agree with me. What's it, Deepavali? Life never goes as planned.
yes, of course. I mean, that is very true.
Yeah. But yes, we as human being, we love to plan. And yes, yeah, actually, honestly, I'm also on the same page. I don't like surprises, but yeah, cool. Never mind. Okay. So see, what I wanted to highlight is that my microservices is a big topic. Okay. Now there is one video which I have find online. Okay. Now please just pay attention to hear that this video will be giving you a quick brief with all of the animations. Okay, because I hope you got the point. I cannot show majority of the thing with a whiteboard, so take a look at the video. Right, I will be keeping my mouth shut. This is, I guess, 10 minutes long video. Okay, but anyways, okay, fine. So are we ready for the video? And in the video it's all over the discussion of microservices. Make sense, everyone? Okay, cool. Okay, shall I play the video? What's everyone ready? Right? And yes, if you have got any questions, so I will be see. If you have got any question, just take a note. Okay, just watch the whole video. Okay, then we will be coming back to the question and answers. Okay, so yeah, there we go.
There's a lot of buzz about microservices these days.
Okay, I hope the sound is coming from the video, right? What say everyone? Yeah, sound is coming, right? Okay, cool. So there we go. Watch the video and enjoy the video.
There's a lot of buzz about microservices these days. Everybody wants to create applications using the microservice architecture. In this video, let's look at what microservices are really all about. But rather than reading out a list of architectural concepts, we will approach this from a completely different place by me telling you a story that you really need to know. Let's go back in time to the old days when we didn't have anything called microservices. In fact, we'll go so far back, we'll go to a time when a computer was big enough to fill the room. You must have seen pictures of one of these things. You would walk up to the computer, you would give it all the instructions it needs to compute, then it would take it and it would execute it. All right. Fast forward a little bit to desktop machines. Again, programs resided on the desktop machine. The program or application contains all the instructions that are needed to execute. So when people would write applications for it, their code would be compiled down and the whole thing would be installed on the computer in one go. And it'd be installed on the same computer. Think of purely desktop only apps, okay? Something like Microsoft Word or a text editor that you install on your machine. This has historically influenced how we write code. When we need to write an application, we would start a new code project and we would add functionality into that project. Need more functionality? Add more code. And so the size of the code base for any given application keeps increasing over time. So what starts as a small code base might end up turning into a large complex code base over time. People realized this. There were best practices that were created to handle large projects. Developers were recommended to break things up into modules. So rather than put all your code into a single mess of a code base, create smaller modules and compose your application from these modules. Small independent parts that were focused on just doing a small amount of functionality. These modules were supposed to be reusable. So a simple module could be added to another project to help another application. See, isn't this awesome? And then once you've created your application this way, you're ready to build this whole application and deploy this on the machine that runs your application. Notice something here. When coding your application, you have all these modular constructs, right? Nice, fragmented, organized pieces of functionality, pieces of code that compose together to form your application. But still, what you're doing is composing them to form one application. And when you build it and deploy it, all those small pieces all get smushed together into one giant ball of distributable that is your final application build. And that's what you deploy to a machine. Again, take the example of your text editor installer or Microsoft Word installer. No matter how the developers of that application have modularized and organized their source code, the final distributable, the final executable is just one thing, but everything smushed together. This is important to remember, okay? Remember this picture. Nice, fancy, modularized, organized structure of the code, but one application, so the final deployed entity, smushed. Because nobody cares how the application looks on the user's machine, right? And everything needs to be deployed on to one machine anyway. This used to work for the most part for desktop applications. People would happily develop and deploy applications this way. And then there came along two things that would revolutionize and maybe even necessitate some changes to the way we build applications. What were those two things? First was the onset of web applications. People started to move away from applications that needed to be installed on the machine and towards web applications that would be installed on a remote server machine somewhere on the internet. And then you, from your machine, can use your web browser to access the result of that execution on the remote machine. Think server-side applications. The server would prepare the HTML that your web application needs to show, and no applications are actually deployed on your machine, apart from your browser perhaps. You just use your browser. The actual application would be deployed on server somewhere, and your requests go to that thing, and that processes it, does whatever it needs to do, and then returns back a response. Now, you might ask me, how does this change things? Well, for the most part, nothing much changed initially. The only change was instead of developers installing their applications on all the different users' machines, they would install them on just one server, and all the users would just point to that server and access that server. This was awesome, right? Everybody gets automatic updates. Very cool. But then the code and the deployment model was still the same. Nice, fancy, modularized, organized structure of the code, but all that composes to just one application and the final deployed entity smushed. Rather than deploying the smush on the user's machine, they were now deploying that smush in one place on the server. Then, at some point of time, due to various different reasons, some people started wondering, there must be a better way. But wait, let's pause the story for a bit and let's look at one other development that's been happening to applications over the years. Turns out web apps have been growing very, incredibly, very complicated over time. The first web applications from the past did very simple, rudimentary things. I don't know, like tell you the time or something, nothing too fancy. But over time, web applications have started becoming better, bigger, quicker, more complicated, bigger scale, bigger user base, bigger everything. And today we have web applications that can, find something from the whole internet in a matter of milliseconds, or find what cabs are available around you all over the world in milliseconds. These are incredible feats if you think about it, and they need incredibly complicated code to be developed and deployed. And this complexity becomes harder and harder to maintain. Hang on, we have nice modular architecture on the code side of things. Isn't that enough to handle the complexity during development time? Who cares about how the application is deployed, right? Well, with the type of applications we are talking about, the complexity needs to be handled not just at the coding side of things, they also need to be handled at the runtime or execution side of things. Having a single thing that you deploy didn't work anymore. This way of having a single application was called the monolithic application or monolithic architecture. Mono means single, lithic means stone. Single stone, monolithic. This is the smush, basically. What are some of the disadvantages of this monolithic model? First, the bigger the deployment, the more challenging the deployment. Let me give you an example. Let's say you want to push a new feature to your big monolithic application, all right? So among all the code commits that you want to deploy, is a single code commit by this new guy the company has just hired. We're not so sure about him. He probably doesn't know much, and he's still learning. But his first code commit ever is just sitting there, and you're worried. What do? Well, you need to test the whole thing before you deploy the whole application. You never know which part of the application that commit might have broken. Well, I'm exaggerating here, of course, but the fact remains, since the whole application is being deployed every time, you will need to test the whole application every time you deploy, because anything in it could have a bug introduced. And yeah, you have automated tests and all that jazz, but it has a problem. Second problem with monolithic architectures, scalability. Here's an example. Online e-commerce sites, they have very unpredictable traffic spikes, right? So let's say there's a sale on some product. People rush to the site like crazy. And after the sale is over, the traffic slows down. Similarly, during holidays, there is a spike and there's a dip. Thankfully, these days, we have elastic servers. So when the traffic spikes up, the number of application server instances are increased. But then when the traffic goes back to normal, the extra servers are retired. That's great. But imagine an entire e-commerce website deployed as a single monolith. This monolith has shopping functionality, user profile, returns functionality, a whole lot of other stuff. Let's say there's a traffic spike on the shopping pages. When the servers scale up, notice that all the other functionalities should scale up as well, even though nobody's using them. They have to scale up because the whole thing is just one single application. So a big e-commerce site has to pay a lot more money to create these duplicate instances of the whole application when only a small portion of the app actually needs to be scaled up during the time of those spikes. There are a few other challenges, but I won't go into all of them now. let's go back to the story, to that one guy who said, there must be a better way. So the idea is like this. Back when we were deploying to desktop machines, we had to install the whole app on a single machine. We didn't have a choice. But wait, now we have web applications. The applications actually reside on a server. The user who's sitting at home on their computer or phone, they don't care where your application is or how you deploy it or how you execute it. They just need one main entry point application to talk to. From there on, you can run a single application on one machine or 10 applications on 10 machines. Nobody cares. So here's an idea. Rather than have the whole application smushed into one monolith and deployed into one machine, why not split the application into smaller mini applications? Then you can deploy these mini applications on different machines. You can have them talk to each other over the network and together work as the bigger application. Take, for example, the e-commerce site. You could create a shopping catalog application that just has the shopping catalog functionality and you deploy it on a separate server. Your order processing is on another server. User profile application is on another server. And let's say when the user wants to see the shopping catalog, the view application, which is another application, makes a REST API call to the catalog application's API and say, hey, give me the list of products to show. And the API returns the list, and then the view application returns an HTML with that list. So these mini applications talk to each other over the network by calling each other's REST APIs to get whatever they want from each other. Okay, well, how would this help? First, the risk of deployment is eased. Making a change to the shopping catalog application, well, it's a separate application. You can test and deploy just that. You don't have to test and deploy the rest of the application. Secondly, scaling, no problem. During the holidays, you scale up only the shopping catalog application. You'll be creating more server instances only for the mini applications that you need. So these mini applications or services are what are technically called microservices. Microservices are a way of breaking your application or service down into standalone independent applications that can be run on different hardware or server instances. They all talk to each other over REST APIs and work together to provide the functionality of your application or product. So all that fancy organization that you've been making to the code during development time, well, you can have fancy organized separation of concerns for your applications in their deployed state as well. So you no longer have one application to build and deploy. You have several individual applications that all do like a small thing each, but they work together, work with each other at runtime to form your actual complete application as far as your users are concerned. Now, what are the advantages of microservices? We've covered this. You have flexibility. Different teams can create and deploy microservices independently. They can put them on different servers or even build them in different languages or platforms. These microservices talk to each other through REST. So it really doesn't matter what language you actually use. You no longer have to use a common language or platform. What else? They can be scaled separately. Right? During the shopping traffic spikes, just scale whatever microservices are most used. The other microservices are unaffected. There are many more advantages, of course, but you also have to realize this opens up a whole lot of questions. For all the advantages that microservices have, they also have some problems as well. Earlier, you were dealing with one application. Now you're dealing with tens or maybe hundreds of mini applications in the form of microservices. So you need to make sure you're not making things worse in general, okay? So you're separating your application into microservices. What does this separation look like? How do you ideally split your application up into microservices? So for example, for every feature you need to add to your application, if you need to make changes to 10 different microservices, it kind of defeats the purpose. So you need to separate these applications well. Then there's a problem of how to make sure your microservices discover each other. On a single machine, on a monolith, it's fairly obvious how services call each other. But with microservices, how do the services know which REST API endpoints to call in which environment? Do you hardcode these URLs? Or do you have a process around service discovery? So there are a whole lot of questions here that needs to be answered. And this in a nutshell is the whole thing about microservice architecture. Answering and solving for these problems is exactly what microservice architecture is all about. And it's a science of its own, and it's even an art of its own. Before we wrap up this video, though, I should clarify that there isn't a right or a wrong way to do these things. In fact, Not all applications need to be architected as microservices, no matter how buzzworthy the term is right now. There are many applications that should be built with monolithic architectures. Please don't believe that microservices are somehow better than monolithic applications. They're just different, and both approaches have their own pros and cons. I hope this video gave you some ideas about microservices.
Yep. So now tell me, how was the video? Was the video making some sense? See, I hope you got the point. All in all, the story is there is not a thing called as best architecture. What say? How many of you have got my point, right? Or there is not a thing called as suitable architecture, right? It depends upon the scenario, cases, and many other things, right? What say? On the same page, right? Okay, so please pay attention that what is the thing that we are not the developer, so we will not be coding up the thing, right? But these are suppose the microservices built by the developers, right? One, two, three, four in this case. So each of the microservices will be producing the logs, right? What say everyone? Makes sense? Each of the microservices will be generating or producing the logs, right? There has to be one centralized log storage mechanism with analytics enabled. What say everyone? Makes sense? Yes or no, right? So this is called as Azure. This is the topic actually. So this is called as Azure Application Insights. This is what we will be going to study. Make sense, everyone? What say? Fine, feel comfortable, right? Okay, cool. Now let's take a break of 10 minutes and then we can start, right? Okay. Fine, right? What's everyone? So let's come out after the break. Okay, thank you. Enjoy the break. See you after the break. Hey, hey, everyone is back, right? Yes, so we are starting up the exercise. Okay, there we go. So I will be going to the Azure portal right now. Then what is the service that which we will be going to study? It's called as application. What's the full name? Insights, right? So I will be searching for application insights. And there we go. You can see from the drop down. Okay, cool. And clicking on create, selecting the resource group, giving it a name, sample test 1, 2, 3, and that's all. Okay, make sense, everyone? Now I will be clicking on this, that is review and create. Let's wait for the validation to get passed. And I will be clicking on create once the validation is done. Okay. Yeah. I will be clicking here, go to resource. And there we go. See, our application insights is ready. Fine, everyone, right? Okay. Now, what is the next step we have to do? Think, everyone, think. Which means my application insights is ready, which is my log centralized log system is ready, right? Which means then centralized log system is ready. Make sense, everyone? Now tell me what will be the next step. Go ahead. What will be the next thing here? We need an application, right? Yes or no? Makes sense. So this application will be sending the logs to this particular system. How many of you have got my point? Yes, no. And this application, what I'm going to do is a simple Python application. Okay. Now the application is ready. Let me show you the application. This is my terminal. Let me go to the desktop. And source PNP active. Yeah. So where is VS Code? Yeah. Yeah. So this is the sample application. Okay. Makes sense. And trust me, this is a simple application with just once the log is sent, it will be sending up the console message that is telemetry send. Okay. And just a simple thing, right? Now, how many of you have gotten a point that how this application means my Python application will be connected to the application inside? What say? I hope you got the point, right? We need to connect the Python application to this log system. Yes or no? Make sense, everyone? Yeah, right. Okay. Now that will be done with the help of a key, and that is called as instrumentation key. Okay, take a look in the chat. So with the help of this key, our application is going to connect to our Azure application insights. Make sense? Now I will be copying this key and I will be pasting here. This part, see? Make sense, everyone? I will be copying this key and I will be pasting here. Yes, no, fine, do let me know. Fine, right? What's everyone? So once I will be copying and pasting this key here, now this application is connected. So what I will be doing now, I will be simply going to the terminal and I will be running the Python application. Can you see the terminal? What is the output it has generated here? See, telemetry sent. Yes or no? Can you all see this, right? Yeah. So I will be just running this application 2, 3 more times. Means I will be sending more logs. Okay. 3, 4 times I have ran this application. See, now I will be coming to here, application insights. I will be navigating through logs and I will be going to the KQL method, KQL mode, and I will be writing some queries. So where is the query? Where is the query? Where's the query? Yeah, here is the query. Let me just copy the query here. Yeah, let me copy the query and run it. Run it 2, 3 more times. Run it. Okay, this is not getting generated. All right, so 1 second. Let me check my terminal. Python 3 app.py. Okay, it's not yet coming. Let me check. CD desktop balance CD. What's this? Azure Application Insights, Python app.py. Okay, now let's check. Come on. 1 second. Let me check the code if I'm working. That's my current code or not. Yeah, this is the code what I believe. VS Code. Okay. Let me. Oh, I think I have copied the telemetry key. Yes, I have copied the telemetry key. Replace it, save it. Let's run it one more time. It's coming as telemetry sent. Go to logs, run it. Okay, it's still not there. Mhm. Have I pasted the correct query or what? It's not working. Okay. Maybe it needs some time to settle. No, it. Let me just run this thing to see. It's not working. Okay, it's showing. Okay. Oh my God, it's not working. be working. That's fine only. Have I opened the correct? Okay, wait, let me check. Okay. It's Azure Application Insights. Okay. Which is this? Okay. Okay. Copy the telemetry key. D00. Python app. Looks fine. Come on, don't be that rude. It should be working fine. Ah, oh my god. Okay, let's come on. Seriously, I don't know why it's not working. Let's do one thing. Let's try to create a new project. Maybe the code broke or something like that. I'm not sure. Now it should be working. Let's try and see. Logs, simple mode. Let's run this query. Wow, it didn't. Oh my god, still the same. Come on. Same. Okay, I don't know, but it was working just 2-3 hours before. Okay. And this should be the result. An image in new tab, it's not why it's not working. Yeah, can you all see this, everyone? That's in screenshot, right? So this is how it was working, right? When you will be typing this particular KQL script, it will be showing you all the timestamps. Okay, but I don't know why it's working now. Okay, but I don't know. I need to check the code, but it was working just 2-3 hours before when I tested it. Okay. But anyways, so yeah. So I'm sending you this lab manual. Okay. I'm sending you the step by step, what say the lab tutorial. Okay. So you please try it on your own. Okay. What's everyone fine, right? So I'm just uploading it in the OneDrive. Yeah, here is the lab document. Okay. Take a look in the chat and let me know if the lab document is accessible to you or not. Okay. Let me know, please. What's everyone? The lab document is accessible. Yeah, right. Yeah. Okay, so again, try it on your own. I don't know what's the issue, but it was working just 3 hours before. Can you see this 3 hours ago? It was working 3 hours ago. I don't know what's the issue now. I don't know, man. My count is coming zero. I don't know. But yeah, anyways, try it on your own. I don't know. Okay, cool. So any questions before wrapping it? What say everyone? Any questions? Fine, right? So that's all. When you will be doing the production level application, you just need to integrate these whole things. So this is one of the many ways how you can do that. But again, okay. That's all, okay. So yeah, is this is the last class for us? Or do we have one more class in the next coming week? One more, right? Okay, cool. So again, in the next class, I will be trying to showing you this thing, but I don't know. Trust me, it was working 3 hours back. Yeah, sorry. Cool. Anyways, so thank you. That's all from my side. Bye, everyone. Enjoy the evening. Enjoy the day. Cool. Thank you. Bye bye. Yes. Bye all.